Well, hi there, kiddos. I hope you all had a very nice, long, and relaxing weekend. It's time to get back to algebra, though, so here we go. We're going to talk about evaluating functions today, which is just like what it sounds like. Back before in Unit 1, when we first started Algebra 1, we evaluated expressions, and when we did that, we plugged in a number and evaluated it. Today we're going to evaluate functions, so we're going to learn a couple of new things. Nothing difficult, but there are a couple of new things. So the first thing we're going to talk about is that functions can be described by equations using function notation. Function notation looks something like this, and it is pronounced f of x because it is short for a function of x. And so we have f of x, it stands for a function of x. This is the same thing as y. And so I can replace f of x with a y. It's the same thing as saying y equals something. It's just f of x equals something, and all it is function notation. It looks funny, but it's actually very useful and can be very helpful if you know how to read it and how to look at it. It doesn't change the equation at all. It just makes evaluating that much easier. So let's do a few examples. I apologize, that got in the way. So to find f of x, all we're going to do is plug in the value of x into the equation everywhere we see an x. And so it's nothing but evaluating. We're going to take what x equals and we're going to plug it in. And so number 1 here says to evaluate f of x equals 4x minus 3 when the domain is -1, 0, and 2. Well, the thing you have to remember is that domain is x. So they're saying we're going to evaluate this when x is these three numbers. So I'm basically going to do this problem 3 times, and the first time I want to do it when x is -1. So everywhere I see an x, I'm going to replace it with a -1. So to find f of -1, I see I replaced the x with -1. I'm going to replace this x with -1, and then I'm just going to do the math. Well, f of -1 will remain f of -1 because that's what we're finding. We're trying to find out the function value at -1. Then we'll just calculate this. Well, 4 times -1 is -4, and -4 minus 3 is -7. And so the function value at -1 is -7. So now we're going to do that again. We're going to repeat this process, but now we're going to find it when x is 0. So now we want to find f of 0. So I have replaced my x with 0 this time. So I'm going to evaluate. The function value at 0 is going to be, well, 4 times 0 is 0 minus 3. So the function value at 0 is -3. So one last time, I know that x is 2. This time I want to find f of 2 because now x equals 2. So I'm going to replace all of my x's with a 2. And then I'm just going to calculate what that equals. Well, 4 times 2 is 8. And 8 minus 3 is 5. So the function value at 2 is 5. And this doesn't mean much to you right now, but we're getting ready to look at a graph, and it's going to help you out a lot because this is very helpful when looking at a graph because it helps you find points on a graph quickly. So we have this graph, and we're going to use it to answer some questions. So we have this lovely little graph right here. The first thing it asks us is to find the value of f of 8. Well, this means they want you to find out what the function value is when x equals 8. So because they replaced the x in parentheses with an 8. So really what we want to know, we know that x equals 8. So right here is where x equals 8. And the point on this graphed line where x equals 8 happens to be 0 because where x equals 8, y equals 0, and so the value of f of 8, that function value at 8, is going to be 0. So really what this means is that y equals 0. When x is 8, y is 0. It gives us an ordered pair on the graph. So B says, what's the value of f of 16? So same thing, they want to know what's the function value when x equals 16. So I'm going to draw a line up here at 16 until it meets my graph. Well, it meets my graph right here, which if I go over to the corresponding y value, I see that it equals 12. So the function value at 16 is 12. So when x is 16, y equals 12. Now part C is a little different. I'm going to change colors because this one's going to work different than the other one because this says for what value or values of x does f of x equal 4. This time they don't give you the x. They say f of x equals 4. So they're basically saying y equals 4. Because remember, f of x and y are the same thing. So now they're telling you the y value. They're saying y equals 4. So I'm going to draw a line right here where y equals 4 across. so that I can see that it hits the graph here and here. So where y equals 4 happens twice on this graphed line. It happens once here and once here. Well, the x value for this one is 4, and the x value for this one is 12. So there are two values. That's why it was worded the way it was, value or values. So in order for y to equal 4, x is 4 and x is 12 because it happened twice on my graph. Part D is very similar. It says, for what value or values of x does f of x equal 16? So now they're saying y equals 16. I'm going to do the same thing. I'm going to draw my line across, and you're going to see that it hits the graph here and here. Well, I'm going to find out those two x values. This first one happens to be the number between 16 and 20, and I'm going to say that's 18. So I'm guessing that counts by 2's. And then it also hits here where x equals 24. So the two values where y equals 16 are x is 18 and x is 24. Now this next one is interesting, and I'm going to use yet another color because it's asking a different question and I want to be able to look at it. So it says, for what values of x is f of x greater than or equal to 10? So they're saying y is a number greater than or equal to 10. That means at where I have y on my y-axis, I'm going to go to 10. I'm going to draw myself a line. I know I have a lot of lines happening now, but I want it to be greater than or equal, which means it can be on this line or it can be above this line. So everything from here all along here is what's going to count, and all I care about is the values of x. Well, right here where it equals is between 14 and 16, so it goes from x equals 15 all the way to right here where x equals 22. And we don't want to write it this way. We don't want to say it goes from x equals 15 to x equals 22. The values of x where f of x is greater than or equal to 0, okay, are all of the values from 15 to 22. So there's a couple of ways to write it, okay? We can say everything from 15 to 22, or we can write it like one of our domain statements, and we're going to say that it goes from 15 all the way to 22. So it is every number between 15 and 22, and it includes both of those because that graph actually passes through or touches those points. So it is all of those values from 15 to 22. And you could write them all out if you wanted to, but it's good enough if we just say it's from there to there. So is this graph a function? Yes or no? Well, I have a picture. I'm going to use the vertical line test. And we've done this before. It has been a while, and so you might not remember, so I'm going to refresh your memory. So I'm going to make a line. And just like before, I'm going to take that vertical line and I'm going to drag it across my graph. And I'm going to look and see, does that blue line ever pass through my graphed line in more than one point? I don't believe that that blue line ever crosses through my graphed line in more than one point, which means yes, it is a function. And the reason it is a function is because none of the x values repeat. That's what makes the vertical line test work. So yes, it's a function, and it's because we have no repeating x values. And you can see that because if you look at your graph, there is never a point where two x values are lined up where you have a vertical kind of thing happening where you have a point here and a point directly below it. Now it asks for the domain and the range. Okay, so we're going to have to go back to that kind of stuff. All right, domain is the x values. So it starts here and it ends here. So it starts at 0 and ends at 26. So the domain goes from 0 to 26. The range starts down here at the bottom at 0 and goes all the way up here to 20 is the highest point. So the lowest point is 0 and the highest point is 20. So it's all the way from 0 to 20. So there is your domain and your range. So that's how we use the graph to evaluate functions. It's actually pretty simple. If you are given f of a number, that means they gave you x. If you were given f of x equals a number, that means they gave you y. Just go backwards and look at the graph. So let's try a couple more. So we're going to evaluate some actual functions now. So this first one, we want to evaluate this function, f of x equals x minus 9, and they want you to find f of 3, which means they have replaced the x with a 3. So I'm going to replace this x with a 3. And so to find f of 3, I just have to do 3 minus 9, which happens to be negative 6. So the function value at 3 equals negative 6. So when x is 3, y equals negative 6. It makes a pretty little ordered pair. This would be a point on the graph. So number 4, it's a little interesting. They have g of x, and then we have x squared minus 3x plus 2. This means the same thing as f of x. It's just a different letter. You just need to get used to seeing different letters. It's okay that it's a g and not an f. It means the same thing. We got to find g of negative 2. So I've now replaced my x with a negative 2. So everywhere I see an x, I'm going to replace it with a negative 2. And because this whole x is being squared, I'm going to put my negative 2 in parentheses because x is a negative 2. If you do not put it in parentheses and you plug it in your calculator, you're going to get a different answer than me. And yours will be wrong. So now we're going to evaluate. Negative 2 squared is 4. Negative 3 times negative 2 is a positive 6 plus 2. So g of negative 2 is going to be 4 plus 6 is 10, plus 2 is 12. So the function value at negative 2 equals 12. So now look at number 5. It says to evaluate the function f of x equals 5x minus 3 for 2 times f of 3. When you see this kind of problem, you are going to start on the inside of the brackets and do that first, and then do what it says outside. So I have to find f of 3 and then multiply it by 2. So to do 2 times f of 3, the first thing I'm going to do, I'm going to put my 2, and I'm going to plug in 3 for my x's. So I have 5 times 3 minus 3. And if you'll remember, order of operations, do parentheses first. Well, 5 times 3 is 15, and 15 minus 3 is 12. So I have 2 times 12, so that equals 24. So 2 times f of 3 equals 24. So the function value at 3 twice is going to be 24. So let's try number 6. It's the same kind of problem, except this time they want us to find 3 times f of 2. So when I do that, I'm going to do 3 times, and I'm going to plug in 2 into this. So I have 3 times 2 plus 2. Order of operations, we'll solve that first. 3 times 2 is 6, plus 2 is 8, and 3 times 8 is 24. It's the same answer as that one, even though they were different functions, because it's just how it worked out. It is coincidence. Every time you have one of these, it will not equal 24. Please do not jump to that conclusion. So let's do just one more. So now you have a table. So several values of a function are shown below in this table. The first thing they want to know is what is the value of f of 3? Well, if I want f of 3, they're saying x equals 3. So right here is where x equals 3. Okay, if x is 3, then the function value is 0. So the value is 0. So what's the value of f of 5? Well, again, they're saying x is 5. Well, right here is where x equals 5. And when x equals 5, the function value is negative 3. Now, c is backwards. Now it says when f of x equals 6. Well, here's the f of x column. So when f of x equals 6 right here, this is the row I'm looking for. But the value of x happens to be 8. So you're going backwards. Now, I really like this next question because it has you extend what's going on, but it's good for you to see. All right, so it says, given the table, if a new function g is defined by g of x equals f of 3x plus 1, we want to find the value of g of 2. That means I'm going to replace all my x's with a 2. So I have g of 2 is equal to f of 3 times 2, because that's what x equals, plus 1. Well, I just have to find out what this is. So g of 2 is going to be equal to f of 3 times 2 is 6 plus 1 is 7. So g of 2 is the same thing as f of 7. Well, if we look up here in our table, if I want to know f of 7, that means x equals 7. Well, right here is where x equals 7. And if you will see, when x equals 7, the value of that is negative 5. So g of 2 is negative 5, because that's what f of 7 equals. They're the same thing. So last one, let the function f be defined by f of x equals 2x plus 2. If 4 times f of j equals 40, they want the value of f of 2j. Well, so we got to plug in what we know, okay? We have 4f of j. Okay, so we have to find out what f of j is so that we can use this. F of x, f of j, a letter is a letter. We're just going to replace with something. So if I know 4 times f of j is 40, to find out f of j, I'm going to divide both sides of this by 4. And that will give me that f of j, that's a j, equals 10. So now that I know that f of j equals 10, I'm going to substitute j into here. So I'm going to have f of j is equal to 2x plus 2. So I just, f of j, f of x, this is equal to that. So f of j equals 10. And if f of j is the same thing as 2x plus 2, then 2x plus 2 must equal 10. So I'm going to solve this for x. I'm actually going to make that a j. Let's keep our variables the same. So we'll make this a j. So f of j is equal to 2j plus 2. All I did was replace x's with j's. I'm going to solve for j. So I'm going to subtract 2 from both sides. So I end up with 2j equals 8. And so when I divide by 2 on both sides, I get that j equals 4. So now that I know what j equals, I can find f of 2j. Well, if I want to find f of 2j, that's f of 2 times 4, which is f of 8. I want to now find f of 8. So I'm going to go back to my original thing. To find f of 8, I'm going to replace my x with an 8. So a lot of things just happened here. So 2 times 8 is 16, and 16 plus 2 is 18. So f of 8 equals 18. And I'm going to walk you through one more time how I did that, because I did a lot of stuff real fast, and I want to say it one more time so that you will see it. So the first thing I did was I solved this for f of j, and I got that by dividing by 4. So I got that f of j equals 10. I then changed this from an f of x to an f of j. I just changed the variables to j's. That's all I did. So f of j is the same thing as 2j plus 2. Well, if f of j is 2j plus 2, then I can do substitution, and I can do 2j plus 2 equals 10, because they're both f of j. So I had 2j plus 2 equals 10. I solved that, got that j equaled 4. I then took that j equals 4 and plugged it into this f of 2j to figure out that I needed to find f of 8. Once I figured out I wanted to find f of 8, because that's what this is asking for, I went back to my original function and I substituted 8 for x and solved, and that's how I got 18. So you will see some of these tomorrow. I'm sure that you will have questions. Please make sure that you ask, but make sure you also have your notes copied down so that you will have something to look at to refer to. So I will see you guys tomorrow in class. Have a good rest of your evening.